A sail is a catchment device designed to receive and redirect a force upon a generous surface area. Traditionally, the surface was engineered of woven fabric and supported by a mast, whose purpose is to propel a sailing vessel. Sails may be configured in many ways to include traditionally understood maritime purposes, as well as land vehicles and solar collection purposes. The rich encyclopedic history of maritime sails suggests alternative uses of the technology well documented. History of sails. Archaeological studies of the Tripolian culture ceramics show use of sailing boats from the 6th millennium onwards. Excavations of the Ubaid period in Mesopotamia provides direct evidence of sailing boats. Sails from ancient Egypt are depicted around 3200 BCE, where reed boats sailed upstream against the river Nile's current. Ancient Sumerians used square-rigged sailing boats at about the same time, and it is believed they established sea trading routes as far away as the Indus Valley. The Proto-Austronesian words for sail, lay, and other rigging parts date to about 3000 BC when this group began their Pacific expansion. Greeks and Phoenicians began trading by ship by around 1200 BCE. Square sails mounted on yardarms perpendicular to the boat's hull are very good for downwind sailing. They dominated in the ancient Mediterranean and spread to northern Europe, and were independently invented in China and Ecuador. Although fore and aft rigs have become more popular on modern yachts, square sails continue to power full-rigged ships through the age of sail and to the present day. Triangular fore and aft rigs were invented in the Mediterranean as single-yarded lateen sails and independently in the Pacific as the more efficient bi-sparred crab-claw sail, and continue to be used throughout the world. During the 16th–19th centuries, other fore and aft sails were developed in Europe, such as the spritsail, gaff rig, jib, Genoa, staysail, and Bermuda rig, improving European upwind sailing ability. In an interesting recent development, an elderly trawler, T.S. Pelican, was fitted with what are thought to have been the unorthodox riggings used by the Barbary pirates in the 16th century. The resultant performance has been remarkable, with the Pelican sailing, at speed, over 20 degrees nearer the wind than any square rigger. Space satellites have successfully deployed solar sails which use radiation pressure or solar wind to propel them. Use of sails. Sails are primarily used on the water by sailing ships and sailboats as a propulsion system. For purposes of commerce, sails have been greatly superseded by other forms of propulsion, such as the internal combustion engine. For recreation, however, sailing vessels remain popular. The most familiar type of sailboat, a small pleasure yacht, usually has a sailplan called a sloop. This has two sails in a fore and aft arrangement, the mainsail and the jib. The mainsail extends aftward and is secured the whole length of its front edge to the mast and its aft corner to a boom, generally also hung from the mast. The sails of tall ships are attached to wooden timbers or spars. The jib is secured along its leading edge to a forestay strung from the top of the mast to the bowsprit on the bow of the boat. A Genoa is also used on some boats. It is a type of jib that is large enough to overlap the mainsail, and cut so that it is fuller than an ordinary jib, producing a greater driving force in lighter winds. A spinnaker is also used on some boats to help move the sailboat faster downwind. The spinnaker is often a colorful sail and can be either symmetrical or asymmetrical. Fore and aft sails can be switched from one side of the boat to the other in order to provide propulsion as the sailboat changes direction relative to the wind. When the boat's stern crosses the wind, this is called jibing. When the bow crosses the wind, it is called tacking. Tacking repeatedly from port to starboard and or vice versa, called beating, is done in order to allow the boat to follow a course into the wind. Modern boats can sail as close as 30 degrees to the wind. A primary feature of a properly designed sail is an amount of draft, caused by curvature of the surface of the sail. When the leading edge of a sail is oriented into the wind, the correct curvature helps maximize lift while minimizing turbulence and drag, much like the carefully designed curves of aircraft wings. Modern sails are manufactured with a combination of broad-seaming and non-stretch fabric. The former adds draft, while the latter allows the sail to keep a constant shape as the wind pressure increases. The draft of the sail can be reduced in stronger winds by use of a Cunningham and outhaul, and also by bending the mast and increasing the downward pressure of the boom by use of a boom vang. Other sail-powered machines include ice yachts, windmills, kites, signs, hang gliders, electric generators, windsurfers, and land sailing vehicles. Sail construction is governed by the science of aerodynamics. Types of rig. Generally speaking, sailing vessels employ two main types of rig: the square rig and the fore and aft rig. The square rig, which reached its maximum development in the clipper ships and trading barks of the late 19th and early 20th century, relies on rectangular sails hung beneath yards, themselves suspended from the masts and set square, the keel of the ship. This kind of rig requires an enormous amount of rigging and cannot sail closer than about 60 degrees to the wind. Few vessels of this type are seen today, other than the spectacular ones used for sail training. Most square-rigged vessels also carry at least some fore and aft sails. The fore and aft rig is far more common. Nearly every dinghy and yacht uses this type of rig, in which the sails are mounted parallel to the keel and are secured to the fore of the ship and to the aft rather than side to side. A large mainsail is often rigged abaft the mast and usually a jib in front of it. The foot of the mainsail is usually extended by a boom. Each sail needs only 2 or 3 ropes for its basic control. Sail aerodynamics. Sails propel the boat in one of two ways. When the boat is going in the direction of the wind, the sails may be set merely to trap the air as it flows by. Sails acting in this way are aerodynamically stalled. Drag, always parallel to the wind, contributes the predominant driving force. The other way sails propel the boat occurs when the boat is traveling across or into the wind. The sails acting as airfoils propel the boat by redirecting the wind coming in from the side towards the rear. By the law of conservation of momentum, the wind moves the sail as the sail redirects downwash air backwards. Air pressure differences across the sail area result in forces on sails including drag and lift. A component of the lift is the main driving force. The sails can also act as airfoils in some downwind situations, e.g., spinnakers and square-rigged sails can be trimmed so that their upper edges become leading edges and they operate as airfoils again, but with airflow directed more or less vertically downwards. This mode of trim also provides the boat with some actual lift and may reduce both wetted area and the risk of digging into waves. In stronger winds, turbulence created behind stalled sails can lead to aerodynamic instability, which in turn can manifest as increased downwind rolling of the boat. Sails are often equipped with lightweight tapes or strands to indicate the airflow in their area. They may be on both sides near the leading edges of the sail, or at the trailing edge of the sail. Horizontal strips sewn into fore and aft sails and V-shaped markings on spinnakers assist with judging their shape from on deck. These may even glow in the dark, using luminous tapes. On a sailing boat, a keel or centerboard helps to prevent the boat from moving sideways. The shape of the keel has a much smaller cross-section in the fore and aft axis and a much larger cross-section on the athwart axis. The resistance to motion along the smallest cross-section is low while resistance to motion across the large cross-section is high, so the boat moves forward rather than sideways. In other words, it is easier for the sail to push the boat forward rather than sideways. However, there is always a small amount of sideways motion, or leeway. The keel or centerboard acts as a secondary foil, symmetrically aligned under the vessel front to back. The sidewise forces induced by the sail create an asymmetrical water flow across the foil, resulting in opposing lift. Forces across the boat are resolved by balancing the sideways force from the sail with the sideways resistance of the keel or centerboard. Also, if the boat heels, there are restoring forces due to the shape of the hull and the mass of the ballast in the keel being raised against gravity. Forward forces are balanced by velocity through the water and friction between the hull, keel and the water. Parts of the sail. The lower edge of a triangular sail is called the foot of the sail, while the upper point is known as the head. The lower 2 points of the sail, on either end of the foot, are called the tack and clew. The forward edge of the sail is called the luff. The aft edge of a sail is called the leech. The curved sail area beyond a straight line from the head to the clew is known as the roach. Typically this is greater in a racing sail and may be absent in a cruising sail. The roach is held in shape by sail battens which may be full length or short. Modern sails are designed so that either the warp or weft of the cloth is perpendicular to the leech. This places the most elastic axis of the cloth on the luff and foot, whereby a stretch can be controlled with folded cloth tabling or rope. Varying tension on the luff and foot with winches, downhauls, or outhauls allows the sailor to adjust the draft to suit wind conditions. Often telltales, small pieces of yarn, are attached to the sail. They are used as a guide when trimming the sail as they indicate the wind flow across the sail. An alternative approach to sail design is that used in junks, originally an Oriental design. It uses horizontal sail curving to produce an efficient and easily controlled sail plan. Sail types. Modern sails can be classified into 3 main categories: mainsail, headsail also known as the jib sail, and spinnaker or downwind sail. Special-purpose sails are often a variation of the 3 main categories. High-performance yachts, in particular some catamarans such as the International C-class catamaran, have used or use rigid wing sails, which are said to provide better performance than traditional soft sails. In particular, a rigid wing sail was used by Stars and Stripes, the Defender who won the 1988 America's Cup, and by USA 17, the Challenger who won the 2010 America's Cup. Most modern yachts, including Bermuda rig, ketch and yawl boats, have a sail inventory, which usually includes more than one of these types of sails. Although the mainsail is permanently hoisted while sailing, headsails and spinnakers can be changed depending on the particular weather conditions to allow better handling and speed. Mainsails, as the name implies, are the main element of the sailplane. A motor, as well as a rudder for the boat. Mainsails can be as simple as a traditional triangle-shaped, cross-cut sail. In most cases, the mainsail isn't changed while sailing, although there are mechanisms to reduce its surface if the wind is very strong. In extreme weather, a mainsail can be folded and a trysail hoisted to allow steerage without endangering the boat. Headsails are the main driving sails when going upwind. There are many types of headsails, with Genoa and jib being the most commonly used. Both these types have different subtypes depending on their intended use. Headsails are usually classified according to their weight and size or total area of the sail. A common classification is numbering from 1 to 3, with a description of the use, for example, number 1 heavy or number 1 medium, light. Special types of headsails include the Genoa, the drifter, the screecher, the windseeker and storm jib. Certain Genoa and jibs also have battens which assist in maintaining an optimal shape for the sail. Spinnakers are used for reaching and running. They are very light and have a balloon-like shape. As with headsails, there are many types of spinnakers depending on the shape, area and cloth weight. Symmetrical spinnakers are most efficient on runs and dead runs, while asymmetric spinnakers are very efficient in reaching. Sail construction. A sail might look flat when lying on the floor, but once it is hoisted, it becomes a three-dimensional curved surface, in essence an airfoil. In order for a sail to be built, it has to be designed in a number of elements which are cut and sewn together to form the foil. In older days, this was rightfully considered an art which was later complemented by technology. With the advent of computers, sail manufacturers were able to model their sails using special computer-aided design programs and directly feed the data to very accurate laser plotters, cutters which cut the panels from rolls of sailcloth, replacing the traditional manual process. The key features that distinguish a fast from a slow sail are its shape related to the particular boat and rig and its ability to consistently maintain that shape. These two features rely mostly on the design of the sail and the sailcloth used. The traditional parallel panel gave way to more complex designs where the panels have different shapes for the top, mid, and lower sections of the sail depending on pressure of the air caused by its flow over the sail surface. Again aided by CAD and special modeling software, the sailmakers use cloths of different weight, placing heavier cloth panels where there is more stress and lighter cloth where there is less to make savings in weight. Older fabrics have the tendency to stretch with wind pressure, which results in distorted and consequently inefficient sail shapes. Moreover, the cloth itself is heavy, which adds to the inefficiency. Synthetic materials such as nylon and dacron were followed by advanced sailcloths made from exotic material yarns such as aramid, carbon fiber, HMPE, Xylon and Vectron. These materials were a breakthrough in sail technology as they provided the raw material in the manufacture of low-stretch, low-weight and long-life sailcloths. Manufacturers were able to use different weights of yarn to weave cloths with exceptional properties. Once the panels are sewn together, the sailmakers completed the sail by placing the finishing elements such as the leech and foot lines, protective patches in the areas where the sail will scrape against hardware, steel rings and straps at the tack and cleats, batten pockets and sail numbers. Lamination. Woven cloth or ribbons of high-tensile fabric inserts can be sandwiched between two layers of PET film and placed in special ovens under pressure to bond into a single body, a process called lamination. The inserts provide the strength and the PET film the continuity and wind resistance. An alternative method is to sandwich a sheet of PET film between two layers of woven cloth. The latter process is popular when using cloth with high strength and UV tolerance, but an open weave. In the latter process the cloth protects the more easily torn PET film. A more complex sail may combine the processes. See also sailcloth. A light weather sail generally weighs around 100 grams per square meter and a rough weather sail tryout weighs around 500 grams per square meter, although modern laminated sails can weigh considerably less than this depending on the fibers specified. Advances in sail materials and manufacture. In addition to advances in the exotic materials and consequent cloths themselves, manufacturers have also progressed the manufacturing process with the creation of glued, molded and laminated sails. Glued sails are regular paneled sails, but instead of sewing the pieces together, the sailmaker uses a special, ultra-strong polymer glue which bonds through the use of ultrasound. In molding, a curved mold is designed and created in the optimum shape of the sail that the sailmaker wants to produce. A film of PET film is placed on the mold and a special gantry hovers over the film, laying the yarns based on instructions of a computer that has the model of the sail. Once this is done, a second sheet of PET film is placed on top and the whole mold is placed in a vacuum oven which causes the materials to bond. The result is a smooth sail which is lighter and has a wider effective wind range. Bibliography. Riosmani, John. The Annapolis Book of Seamanship. Simon and Schuster, 1999. Chapman Book of Piloting, Hearst Corporation, 1999. Marino, Emiliano. The Sailmaker's Apprentice. International Marine, 1994. Herreshoff, Halsey. The Sailor's Handbook. Little Brown and Company, 1983. Seidman, David. The Complete Sailor. International Marine, 1995. Jobson, Gary. Sailing Fundamentals. Simon & Schuster, 1987. Marchage, Cheslaw A. Sail Performance, Techniques to Maximize Sail Power, Revised Edition. London. Adelaide Coles Nautical, 2003.